Okay, question 6. Diagram shows two concentric circles, center O and ABC are points on the larger circle. D is a point on the smaller circle right here. ADB is a tangent to the smaller circle, and BCO is 65. Show that ABC and ADO are similar. So let's mark out where these triangles are, okay? So ADO is right here. ABC is right here. All right. So what is similar about them actually? Right? Where they share one common angle. Right? Can you see that? They share DAO, this red color angle right here. And then you both know that since ADB is a tangent, right? And AD is actually perpendicular to OD, right? Where OD is the radius of the small circle. And how about ABC? It's actually also a right angle triangle. I mean, right angle, right? Why? Because this point is actually touching the circumference of the circle. The base is the radius or diameter, right? So yeah. So part A, actually you can just say that you know that ADO actually equals to 90 degrees. Why? Tangent. It's E and T is perpendicular to radius. Right? ABC equals to 90 degrees. Why? Angle in a semicircle. Right? And you know that what? The common angle, which was DAO and BAC, right? DAO equals to angle BAC, right? This is a common angle, right? Oh, sorry, this one can say therefore angle ADO equals to angle ABC. All right, and therefore triangles ABC is similar to triangle ADO. Why? Because of triangles property. Okay, shown. Okay. So part B, find the ratio area of triangle BOC and to area of triangle ADO. Okay, so I'm just going to remove all these markings. Okay, but they want you to find the ratio of the area BOC and ADO, which is this yellow one. Yellow, no, green to yellow. Yes, green to yellow. Okay. So what is a common thing that they share? They share this same line, right? Which is the diameter of the bigger circle, right? And how do you find this green triangle? You gotta find it from this big purple triangle, right? That is your only way you can find this green portion right here. Because from this purple one, this purple is made out of yellow and green, right? And you also know that this ADO and DOB, they are the same triangles, right? So naturally their areas are the same. And yeah, okay. And you also need to find this quadrilateral ODBC. Okay, so, okay, never mind. Let's write it out before I start to get lost. So, we're gonna use like similar lengths, right? So, B, since AC is equals to 2AO, right? So, area ADO equals A over area ABC, which is the big one, right? Is 1:2, right? Squared, right? It's 1:4. So essentially, you're saying that area ADO has 1 unit, area ABC has 4 units, right? And then, how do you find this quadrilateral ODBC, which is, oh, there's a lot of colors. This orange one that I'm highlighting right now, if you can see, ODBC, this orange quadrilateral, essentially is big triangle minus ADO, right? How do you do that? We actually can do that, right? Because we already know the information. So area of ODBC actually equals to 4 minus 1. Right? So that's 3 units. So ODBC is 3 units. And now we are one step closer to finding what the green area is, right? So green area, how do we find it? We know that orange ODBC is actually made out of green area plus this triangle, right? And we just now established that this triangle is actually same as the yellow triangle ADO, right? They are all 1 unit each, 1 unit, like that. Okay, so to find BOC, area triangle BOC, right? You just have to take 3 minus 1, that's 2 units, right? Why? Got to write area of triangle BOD is equals to area triangle ADO. Okay, and they're both 1 unit. So therefore, their required ratio is just 2:1. Okay. Okay. Okay, I'm just gonna erase this once again before it gets too confusing. So radius of a smaller circle is 3 cm, find shaded area. Okay, so you know DO is 3. Okay. And then they ask you to find a shaded area. What's the shaded area made out of actually? It's just this big circle minus a smaller circle, right? So that's what they want you to find, essentially. And you just need to find the area of the big circle first, which is what? C. Area big circle goes to pi r squared. And what's our r, actually? That's something we don't know, right? So that is what we have to find. Okay? So how about our smaller circle? Do we know? We know, right? Area of small circle actually equals to pi, what? R cubed, where r equals to 3. So 9 pi. Okay? Okay, so now back to the big circle. How do we find the radius of the big circle? OA, right? We can actually find using Tuakaso. Why? Because this is actually a right angle triangle and it's simple, right? But what do we need to know for, what information do we need to know for Tuakaso? You just need to know this value of this angle, right? And how do we find it? You can just take it from subtracting the other two angles in this big triangle. Okay, so angle what? DAO equals to 180 minus 90 minus 65, right? That's equals to 25. Reason? Angles sum of triangle. Okay, and then, okay, so now this is our reference angle. We have our opposite, which is our DO, which is, yeah, which is 3 cm, and our OA, which is what we want to find, which is our what? Is that our hypotenuse or adjacent? It is our hypotenuse, right? Because this is our adjacent. Okay, so we need O and H to our castle, so we use sine, right? So we sine 25 equals to O over H. What's O? O was 3, right? Which is the radius DO. Over the hypotenuse, which is AO, right? And DO was actually 3. AO is the thing that we want to find. So what? AO is actually equals to 7.0986, right? And now we can finally find our area of our big circle. So area, big circle, right, equals to pi r squared, okay? Where r is actually equal to 7.0986 whole thing squared, okay? And then area of shaded equals to what? Big circle minus small circle. So you just have to plug in all your values, which you already find. This is 9 pi. This is this, right? And your final answer should get 130 cm squared. Rounded off to 3 SI. All right. Okay. You're done.